gives copper 2 oxide and carbon 4 oxide. Those are the products when this is subjected to heat. Then on reaction with dilute acid such as hydrochloric acid, it decomposes to give copper 2 chloride plus water and carbon 4 oxide. Zinc. It is a moderately reactive metal. It does not occur free in nature, but it is found mainly in calamine and zinc blend. Calamine, then zinc blend. Zinc blend is ZNS, zinc sulfide. So those are the ore of zinc. Extraction. The zinc ore are concentrated and then roasted in air to yield zinc 2 oxide or zinc oxide. The oxide is mixed with coke and heated to about 1300 degrees centigrade to yield zinc and copper or carbon 2 oxide. It is yielded by the process of extraction, but this time around it is not by electrolysis, it is by reduction, where carbon 2 oxide can also be used to reduce zinc 2 oxide. What am I saying? When you have your zinc ore and it can be reduced by coke. Coke is carbon. Where you have zinc plus CO, which is carbon 2 oxide. This acts as a reducing agent. Another reaction, which is also common here, is the reaction of this zinc oxide with carbon 2 oxide, where you have your metal and carbon 4 oxide. Here, the coke, which is carbon, reduces zinc oxide to zinc and carbon 2 oxide, while here, carbon 2 oxide reduces zinc oxide to zinc and CO2. And these two species act as a reducing agent, as a transition metal. It deviates from the real transition metal because of its electron configuration. It has only +2 oxidation number, its metallic ions are not colored, and it is not used as a catalyst. All the properties of transition elements are simply they have variable oxidation states, their ions are colored, and they are used as catalysts. But zinc is an exception due to the fact that it has fully filled d orbitals. It has 10 electrons in its d orbitals. That is why it does not behave like the true transition elements. They are called pseudo transition elements. Pseudo means false. It means false. Pseudo means false. So they do not behave as a true transition element because of the fact that their d orbital is fully filled. That is why it does not have a variable oxidation state. It has a +2 state. This metallic ion is not colored because of the fact that the electron on the d orbital is fully filled, and it is not used as a catalyst. Physical properties of zinc. 1. It is a bluish white solid with luster. 2. It has a relative density of 1.7. 3. It is malleable and ductile. 4. It has a melting point of 419 degrees centigrade. 5. It is a good conductor of heat and electricity. Chemical properties. it reacts with oxygen to form zinc 2 oxide. It reacts with oxygen to form zinc 2 oxide. This is the reaction. It reacts with water to produce zinc 2 oxide and hydrogen gas. 3. It reacts with acids and alkalis to liberate respective gases and form zincates 2 and hydrogen respectively. And this can be demonstrated by the reaction of zinc with hydrochloric acid. Action of zinc on H2SO4, that's tetraosulfate 6 acid, and also action of zinc on triazonitrate 5 acid. In these 3 respective reactions, it can react with dilute and concentrated form of hydrochloric acid to give zinc 2 chloride, and hydrogen gas will be liberated. While in the reaction with tetraosulfate 6 acid, you have it only reacts with concentrated tetraosulfate 6 acid, where it is being oxidized to sulfur 4 oxide. You have then, in the case of this, it reacts with this to give. So, with respect to the above acids, in the case of zinc, with hydrochloric acid, it reacts with hydrochloric acid dilute form or the concentrated form to give zinc 2 chloride and hydrogen gas. Hydrogen gas is liberated here. In the case of the reaction of zinc with tetraosulfate 6 acid, which is the concentrated form, because it does not react with the dilute form because of the position of hydrogen in the electrochemical series. So it reacts with the concentrated form to give zinc sulfate, water, and sulfur 4 oxide. Here you have hydrogen gas, while here you have sulfur 4 oxide gas. And in the last case, which is the triazonitrate 5 acid, it also reacts with the concentrated form of triazonitrate 5 acid to give zinc 2 triazonitrate 5, water, and nitrogen 2 oxide. So in the reaction with triazonitrate 5 acid, nitrogen 2 oxide is a gas that is evolved. In the reaction with tetraosulfate 6 acid, it is sulfur 4 oxide that is a gas that is evolved. And in the case of hydrochloric acid, it is hydrogen gas that is evolved or liberated. So these are the respective products when zinc reacts with the following respective acids. Tests. How can zinc 2 plus ion be tested for? On reaction with sodium hydroxide, it forms a white precipitate which is soluble in excess sodium hydroxide. Sodium hydroxide in little and in excess. In excess, in little, it forms a white precipitate which also dissolves in excess sodium hydroxide, which is soluble in excess sodium hydroxide. There are some other salts that also give the same reaction. These 3 ions, they give the same reaction. So how are we going to know whether it is zinc 2 plus? Even though in little of this, you have a white precipitate being formed, and the precipitate is soluble in excess sodium hydroxide. Also, this gives similar results, and aluminum 3 plus also give similar results. How is zinc 2 plus be differentiated from other ions? Is simply by aqueous ammonia. So out of all these ions, it is only zinc 2 plus ion that is soluble in excess aqueous ammonia. lead 2 plus and aluminum 3 plus are insoluble in aqueous ammonia. It is only zinc 2 plus that is soluble in aqueous ammonia. So that is the distinguishing test that differentiates zinc 2 plus from all other ions. Uses: it is widely used for galvanizing iron and steel to prevent rusting. 2. It is used in making alloys such as bronze is an alloy which comprises of copper, tin, while brass is an alloy which comprises of copper, zinc. So here, let me use Carnage bronze. Carnage bronze. In the case of Carnage bronze, it has copper, tin, and zinc. So zinc is present in Carnage bronze, while also in brass, copper, zinc. So zinc is also present. So that is why zinc can be used as an alloy. It is also used in making dry cell compounds of zinc, zinc 2 oxide, known as zinc oxide. Preparation: it is prepared by burning zinc in air or by heating its nitrates and carbonates. When zinc is burnt in air, it gives zinc 2 oxide. Also, its nitrates